From Microbe TV, this is TWiP, This Week in Parasitism. Episode 151, recorded on May 1st, 2018. Hi everybody, I'm Vincent Racaniello, and joining me today here in a really nice sunny New York City, Dickson, Despommier.
Hello, comrade.
What is May 1st?
Exactly. I couldn't resist.
Also joining us from a remote location, Daniel Griffin.
Hello, everybody.
How do you do?
You should be sailing, shouldn't you, Daniel?
Well, yes.
I should be. It is beautiful here.
After TWiP, you can zip right on out.
Yeah, work gets in the way. Yeah, well, there you go.
I think that's an expression, right?
Yeah, it probably is.
It is an expression, but it is a nice day, although it's kind of chilly, right? No.
No, it's nice out right now.
Yesterday was chilly.
Yesterday was very chilly, surprisingly chilly, with a little rain. Today, it is gorgeous.
This is a funny email I just got from some producer. He's a company called WAG TV in London, and they make a science program called Strange Evidence.
I got an email from them too. I have to respond.
And they're looking for a parasitologist, and they're coming Sunday, and they want you to be here. So you should go.
You think?
But they said, "Hi, Vincent. In our research, we came across your work and your appearance on the Dr. Oz show."
Yeah, but he said that to me too. But
I never appeared on the Doctor. He's full of it. He's just He's trying to flatter you.
Yeah, well, that's not a flatter.
Why don't you do it, Dickson? You don't have anything to do on Sunday.
Well, actually, we've got our grandson with us on Sunday, and we're going to go to the Bronx Zoo. So I don't know.
You should go to the Bronx Zoo. I don't think this is worth your time. Don't you, right, Daniel? Don't you think this is a scam?
You might be willing to edit this out in the meantime.
I have to say I'm not familiar with WAG TV.
Me neither.
I don't know any of our.
He gave a list. He gave a link though that you could go to some of their shows.
But he told you he saw you on Dr. Oz and me, and neither of us. I have never been.
He must have been hallucinating.
In fact, I wouldn't go on Dr. Oz.
That's correct. That's exactly.
Would you, Dr. Griffin?
No, I wouldn't actually.
No. When I saw Dr. Oz doing an advertisement for Turkish Airlines, I said, "What's
wrong with Turkish Airlines?
That's owned by the country of Turkey."
Is that bad?
Well, look who's the head of it.
Oh yeah, okay. That
I wouldn't do anything to support that person. Anything.
Daniel, what were you going to say?
No, I was going to say, it comes up, and it's an important thing in medicine, is that there's a certain credibility and I think a certain responsibility when you join the profession. And I think part of that commitment is to things that are evidence-based.
Right.
And then if you stray outside that, I think you have to be really clear and sort of humble and say, listen, this is a personal opinion. Because I have an MD, because you think of me as a doctor, this is not, up to the professional standards, and I think it's really important. And so I think I'm a little careful. I don't want to be someone who discounts or who gets in areas where there's no evidence and then somehow claims that I know the right answer. I'm always taken back when I read these guidelines and they have expert opinion based on no evidence, and I'm sort of wondering how you can be an expert when there's no evidence. So I always feel like it's important to acknowledge that and say, this is an area that we do not fully understand. And if I say anything, I'm giving you an opinion, not really as an MD, not as a professional, just as sort of a person.
Yeah.
Because I think that there was a great, I think there was an article recently, they talked about the several types of medicine. And so there's evidence-based medicine, there's eminence-based medicine.
Very good.
That's right.
And then it moves into like rhetoric, eloquence-based.
Yeah.
But I really
opinion-based medicine.
Yeah, opinion-based. So yeah, that's where I was going with my.
It's interesting that you should have even brought that subject up, because last night my wife and I were watching Anatomy of a Murder, the movie, and James Stewart is the defending attorney. He has a person of interest who was actually witnessed to have shot the bartender. I don't know if you know the gist of the story, but at any rate, at some point during this trial, it evolved that this serviceman's wife was raped and brutally beaten by the bartender. And this guy comes back to the bar with a gun and points it right at the guy and point blank shoots him and kills him. And then calmly walks away and says, you probably want to call the police now because that's the basis for this case. So they called in 2 psychiatrists, and this is where I'm going to talk about what Daniel just said. Because the first psychiatrist comes in and says, he's a younger guy. It's Orson Bean as the as the young psychiatrist. And he says, well, what I see here from what the case was described, and he also got to interview the witness, was that he was temporarily unaware of his surroundings. And there's a term for this that he used. And then he says he was unaware of the reality of what he was doing, and he was going through the motions. And then afterwards, he was remorseful, but he realized that he had satisfied something that he needed to do. And he gave a psychiatric reason for it. And then the other, of course, the offense, the ones that were trying to prove this guy guilty, calls in their own psychiatrist, an older gentleman from Johns Hopkins University, and completely is the opposite opinion noticed. And he didn't even know who the person was, the accused. And he said, well, in my experience and he got it very anecdotal. And then this really brought out the difference between having actually interviewed somebody and found out a little bit more about them and someone who just heard about it and given parts of the facts, but not the whole thing. And it was quite funny to see this duel between this very young psychiatrist and this very sage old psychiatrist from an august institution.
Opinions. It's
opinion. That's the whole deal.
My opinion.
And by the way, the case resolved itself. The jury acquitted the man as a temporary insanity case, and quite interesting, really.
Speaking of case,
yes,
let's talk about our case from TWiP 150.
Good saying.
Yeah, I'm glad you did that. I could have we could have had a whole episode on the discussion about.
But in my opinion, we should probably cut this short.
All right. So if you 2 eminent professors think we should move on, I will defer.
Please.
All right. So let me remind or introduce for the first time, if someone's tuning in, our case from TWiP 150. And I had taken everyone back up to the Costa Rican border, to the archipelago. We had traveled by boat. We'd gone up the stream, and we were at a mobile medical clinic working with the organization Floating Doctors. And we had a mother come to see us, and she was concerned about her 2 children who had a very itchy rash on multiple parts of the body. We focused on one boy, and this is the 6-year-old boy. And we get a description that the itchiness is worse at night. The rash involves the buttocks, the arms, the genital area. There's nothing out of the ordinary as far as his past medical history than other would be expected in this area. And we had described the setting in the previous case. And we had said this was a small village, several hundred people, and they were living in these homes that have slat wood floors that are slightly separated, the slats, so that things can kind of be swept or can fall through. There's an overwater toilet. There's dogs, there's pigs, there's chickens. There's no electricity, and all the water collected in this area is collected off of the roofs. We actually introduced that as one of the first sort of technological advancements. Is someone in the village ends up with a tin roof, and water can now be collected. And even with a number of tin roofs now in this village, still not a lot of drinking water. People are drinking about a cup a day is actually the average water consumption, which is actually shocking. You're in the tropics, right, and they're drinking about a cup of water a day.
Wow.
We examined the rash, and we actually introduced for the second time dermoscopy. And we described that under dermoscopy, we are seeing these, I think Vincent put in the show notes 1 centimeter, but they're maybe a little bit longer. But there are these long brown lines. There's a little bit of clotted blood, and there are these little chevron or deltas at the end that we're actually seeing. And I think Dickson had asked, or Vincent, I'm not sure which, but is this something? And about when the organization first went to this community, I would say about 20% of the kids had this affliction, I will call it. And as they've come back repeatedly, it has dropped. But there's certain areas where this particular affliction is well known, common.
Affliction. We had a number of guesses. Peter writes, "Greetings, TWiP team. Here are my thoughts. From the description of the rash as 1 sonometer, long brown lines, clotted blood deltas at the end, my first thought was cutaneous larva migrans caused by migration of animal hookworm larvae into the human epidermis. However, the locations of the rash and the short length of the brown lines make me think that a more likely diagnosis is scabies, caused by small mites, Sarcoptes scabii, burrowing in the skin. Further reading reinforces this idea. The itch is described as insidious and relentless, and often worsening over a period of weeks, and typically worse at night. The scabies burrows are described as brownish irregular lines with scaling at one end and sometimes a vesicle at the other end. Scabies mites less than 0.5 millimeter long should be visible in skin scrapings, will not resolve without treatment, only be cured with prescription medications that kill the mites. There's also a danger that scratching could lead to secondary bacterial skin infections. Permethrin is approved for use in people 2 months of age and older and is considered to be the safest and most effective treatment. Ivermectin is also effective but is contraindicated in young children. While medications can kill the mites and eggs quickly, the itching and rash may initially become worse. There can be a persistent allergic reaction to dead mites. Antihistamine pills can help control the itching, and topical hydrocortisone cream may also be of benefit, as can antibiotics to treat secondary bacterial infections. Mm-hmm. All right. Dickson.
I knew you would give me the next one.
You want me to give it to Daniel?
No, just tell me how to pronounce the name.
No, there's a pronunciation.
I see that. So Peter writes.
Make us proud.
I will try. This is the parentheses approach. Aquarja. TWiP. That means greetings, I guess. From Dublin, where the sun has finally appeared, temperatures at a relatively scorching 16°C. For Dublin, that's really hot. To investigate this case study, I was joined by parasitology lab mates Gwen Deslipper and Paula Tierney. The rash...
I think Peter's going to have to send us a little vocal so that you can...
Yeah, you know what? I would appreciate that. I really would.
Just for the word.
I would.
Well, he did. He sent us a recording of Obama doing it last week.
Yeah, right. The rash made us think of hookworm, schistosomes, and scabies. That's a broad range of diagnoses. Schisto was quickly dismissed due to the line marks observed. After lots of consulting, images of cutaneous larval migraines and scabies rashes, while micro-dissecting Daniel and Dickson's description of the images, we settled on scabies. This was largely due to the lines being described as linear and also 1 centimeter long, which does seem too short for hookworm. I know Daniel said that he would like it if people were able to realize that they can start making diagnoses based on what they have already learned without consulting the literature, but we were currently 5 for 5 on TWiP, so are not taking any chances. Literature confirmed that scabies is endemic in Panama, common in children, found all over the body parts where it was observed on the boy, and itching increases at night. So we would like to lock in our answer as scabies caused by the skin mite, Sarcoptes scabii. Confirmation of examining skin scrapings under microscope for adult mites or eggs. Pyrethrum treatment for the whole family. I have been slowly listening to the back catalog of TWiP on my commute. Every now and then I come across something I would like to comment on, but put it off until I am fully caught up. However, something was in episode 105 that I didn't want to forget. Vincent mentioned having a copy of J.D. Smith's Introduction to the Animal Parasitology signed by W.C. Campbell. How cool. Dickson said Smith was a British parasitologist. I will have to indulge in the popular Irish pastime of correcting famous Irish people being called British. James Desmond Smith was born in Dublin, Ireland in 1917. I walk past his portrait every morning on my way to the lab. One of my favorite stories of his time at Trinity College, Dublin, is how he enthused a young student in the field of parasitology by inviting him to join his dissecting a fish, which he removed tapeworms from. The young student was W.C. Campbell. Whenever I see students getting excited when finding their first parasites in wildlife hosts, I now think another potential future Nobel laureate. Another point that keeps coming up when listening to the back catalog is the debate over the ability of Toxoplasma gondii to influence non-rodent host behavior. It may come up in an episode that I have not gotten to yet, but just in case, I thought you might be interested in this paper, Morbid Attraction to Leopard Urine in Toxoplasma-Infected Chimpanzees. Pierrois et al., 2016, in the issue of Current Biology. Slane, Peter Stewart, and in the TCD Parasitology Lab.
I think we should do this paper sometime. It's looks good. It's in Current Biology.
We probably should. Maybe we take a break just for one moment. Could you please?
You're going to break there, Dickson?
No, but if you could lower the blind, the sun is going to hit my retinas and burn out my ability to see.
You know, while you're like being, I guess, attended to avoid your blindness.
Catered to. So that's good. That's good. Perfect. Thanks. That's much.
I could see that. I could see that. Just about. I was watching it come down, and now, like, you know, the anticipation that's been ruined. But so I don't know if you two have had a chance to look at this paper, but it's you know, I maybe I like this topic, and I'll suggest maybe Dickson doesn't like this topic. The idea of toxo affecting human behavior.
This is not humans. These are chimpanzees.
Well, that was the interesting. What you know, having read this paper, what the authors suggested is that if you really wanted to see this impact, you would want to go back to, I guess, a different animal other than humans that maybe evolved in a context where there was some sense to toxoplasma and maybe some continual evolutionary pressure to maintaining whatever impact toxo might have on behavior to allow it to propagate. It's a very short paper. There's basically one figure in the paper, right. And
right.
But I don't know. Would I be correct in saying that? I'm kind of curious by papers about toxo affecting human behavior, and you're kind of.
Well, remember what we started out saying. I want to see the evidence. I want good evidence.
You know, John Boothroyd, we had on the show. He's an expert in toxoplasma.
He's one of the leading experts.
And we asked him, he said he didn't believe any of the data about humans. Anyway.
That was a while back. Maybe there's some more data.
All right, well, this is so short. Next time we can do it as a snippet.
Exactly.
It's so short.
I like that.
Yep.
So short. Daniel, you're next.
Okay. Alice writes, "Good morning, hosts. Alice here, writing from Syracuse, where it is a beautiful spring morning, bright sunshine, blue skies, and 3C right now, warming to 10C later today. The best part, no snow for the next few days. As you may know, Syracuse is the frequent winner of the Golden Snowball Award, a snowfall accumulation contest between 5 central New York cities. We are set to take the crown again.
Oh, no.
153.6 inches, 390.1 centimeters of snow so far this season. But enough about the snow. Onto the case. So we're moving to a very different part of the world where they don't get snow. No. Onto the case of the 6-year-old boy. And she says, with cutaneous larva migrans. I base my diagnosis on the intense itching, rash location morphology, and presence of definitive hosts, dogs. It was mentioned that many children in this village have this rash, which they likely picked up playing in soil contaminated with Encyclostoma brasiliense larvae. Dickson mentioned that the rash had a serpiginosity.
I did?
Well, yeah, you did, actually.
Oh, dear.
Well, Daniel remarked it was more linear, which is a little puzzling. But given the length of the lines and lack of other symptoms, it sounded like creeping eruption. Oral anti-helminthics, such as ivermectin or allbendazole, would take care of the worms, and not playing in contaminated soil would prevent reinfection. I look forward to the next podcast. Thank you for all that you do, Alice. And Alice is a senior research support specialist at SUNY ESF.
Right.
Dylan writes, "Hi, TWiP hosts. I'm going to jump straight into the case study this week. My guess is scabies caused by Sarcoptes scabii. Fertile female parasites burrow into the host skin to lay their eggs, and the molt feces of the young in the tunnels are what cause the itchiness and rash. So this is delayed by a week or so. Known to be worse at night, which is experienced by the boy. I suspect the 1 centimeter brown lines are the tunnels dug by the females. Diagnosis commonly completed by viewing a skin scraping under a microscope, would treat with an anti-scabetic such as permethrin. Symptoms may last a little while as the dead mites would cause irritation. Thanks for the great case study. I really enjoy using them to keep my parasite knowledge up to date.
About that. Sarah writes, Dear Podfessors, nice. I am writing in with my case study for the itchy children from Panama described in TWiP 150. I've had to guess again, no matter what the case is. I heard you read the responses to case in TWiP 149. I didn't write in with a guess, even though I would have got it right. My diagnosis was cutaneous leishmania, but I thought it was too soon after the last case of leishmania, so I searched for an alternative explanation and found none. My stupidity lost me another shot at winning a book. Oh, well, my guess for the new case will have to be cutaneous larval migrans. It's caused by the larvae of animal hookworms ending up in human hosts and not being able to complete their life cycles due to missing/different environmental cues. Where animals are free to wander and defecate in soil hospitable to the L3 larvae, humans can pick them up when they penetrate the skin. Daniel mentioned that the rash he saw is common in children in this area. My thinking is that young children crawling/sitting on dirt floors in combination with a wide variety of animals being around could easily lead to CLM. According to PD6, which is our 6th edition, an inflammatory reaction to the migrating larvae develops within days after penetration, and PD6 also lists the common areas of the body where such rashes occur, including the arms, trunk, and genital areas, as reported in our case. Treatment of choice is oral antiemetic therapy such as albendazole or ivermectin. If I am right, and I happen to win the book, I'll add it to Science Girl, Glasgow's ever-growing library, and take it out with me on our outreach missions. Fingers crossed. Cheers, Sarah in Glasgow.
Yeah, interesting. We're getting a break between two possibilities, aren't we?
We certainly are. We certainly are.
Daniel.
Kevin writes, Dear TWiP, greatly enjoyed your recent podcast, which I just discovered. I studied parasitology and medical entomology in 1980 and the Liverpool School of Tropical Medicine, but haven't really worked directly in the world of parasitology. TWiP 150 cries out for an immediate diagnosis. But in order to avoid the available heuristic, where one relies on the first thing that memory recalls, I suggest making a little list of possibilities. Reference for the available heuristic: thinking fast and slow. Daniel Kahneman, 2011. I used to exhort medical students and residents to make a 3-item differential diagnosis at the very least before fixing a definitive diagnosis. Your last podcast involved the ulcer of cutaneous leishmaniasis could have benefited from a little digression into other ulcer etiologies, such as cutaneous tuberculosis, yaws, sarcoidosis, etc., before fixating on the one true thing. Differential diagnosis for TWiP 150. Flea bites, poultry lice bites, for example, Menacanthus stramineus, fungal infection, for example, ringworm, though not very consistent with the clinical case. However, the likeliest candidate for the diagnosis is infestation with Sarcoptes scabiei. The dermoscopic findings are typical, see reference, as are the facts of the rash distribution and itch that is worse at night. Children are often more affected due to their tendency to increase skin-to-skin contact. I saw a case at the Salvation Army Clinic in Chicago in the 1990s in an alcoholic who lived at a shelter. He appeared to have typical Norwegian scabies. I was able to obtain skin scrapings and identify the mite under low-power microscopy. I applied Lindane from the neck down, thinking him incapable of fastidious application of the remedy to every nook and cranny. A few weeks later, I saw him vastly improved. Please consider mentioning delusions of parasitosis, which can afflict more sensitive patients who are diagnosed with worms and ectoparasites. The diagnosis can get under their skin. Thanks for a great educational and entertainment service. Kevin Carney, and he's writing to us from Liverpool. And he's got a couple of references here. He does a New England Journal where they've got a crusted scabies picture. Recent study in Fiji using ivermectin. That was 2015 New England Journal. And then BMG case reports where they actually describe the diagnosis of scabies using dermoscopy.
Sounds like a professor, doesn't he?
Does.
He's saying, the availability heuristic. I always tell my students, to do this, and that's great. I love it.
Right.
We have one from Dan who writes, Dear Trypanosomes.
Pretty good.
It's been a while since I was in Central America, but I don't need to travel far to find a kid with scabies.
Roger
the
that.
Intense itching, excoriation, and distribution of the rash puts this high up on the differential for this case. Symptoms are caused by an immune response to female Sarcoptes scabiei mites tunneling through the epidermis, depositing eggs and feces as they go. That's very poetic, isn't it? Transmission by person to person. Dermoscopy is an accurate and practical way to confirm diagnosis. Dr. Griffin described a characteristic appearance of a linear or serpiginous burrow trailing behind the triangular head of the mite. Treatment, topical permethrin for the whole family, repeated after 2 weeks. Oral ivermectin also works. Secondary bacterial infection is common. Scabies is a disease of poverty, apparently endemic in that part of Panama. Community health education and access to primary care can reduce its impact. Mass drug administration may be an option. It was great to hear more about the floating doctors. Volunteering with them is on my to-do list. If it ever happens, I'll send you a case study. Hasta la próxima vez. Dan is in London, UK.
Right.
Dickson.
Yes. No, that was the last one.
I'm sorry. Could you refresh your screen? I'd put a new one in just as we began because it came in. You hit the little refresh.
Yeah, but that's at the top of the screen.
It's at the top of the screen, the little curly Q that says refresh, and then you scroll back down.
Yes,
again
sir.
It's done, and you will see the email.
It's Alistair writes.
Yeah.
Dear TWiP, I've really enjoyed your show since a colleague in my lab introduced it to me a few weeks ago, and I was tempted to send in my diagnosis.
Last week.
My diagnosis last week, that's right. But I didn't trust my own judgment, even though I thought cutaneous leishmaniasis, so I thought I'd give it a go this time around. I admit that most of it has been through Googling the symptoms and some quick searches of PubMed, but let's see if it's right. I won't go into too much detail, but I've arrived at the conclusion of ectopic cutaneous schistosomiasis. Having skimmed a few papers on the subject after Googling the symptoms, it seems fit. The presence of the water toilet and the close proximity to rivers, streams, etc. in the area led me to this conclusion, along with the characteristic rash, which, according to the paper cited below, is a common sign of this type of schistosomiasis. It makes mention of groin, genital rash, and the spread to the trunk as well. Photos I have seen in the process of looking up these symptoms seem to match your descriptions as well, so I'm hazarding a guess. I look forward to hearing your next show. I thought I'd add a bit of my own work as well here, as it could be interesting, especially with regards to diagnosis in these remote settings. I decided to include this when you mentioned about the lack of PCR, etc., in these resource-limited settings. I'm currently working on a project at the University of Bristol in the virology department on LAMP, which, if you're not familiar, is an isothermal PCR-like assay which uses 6 primers, which form dumbbell structures with self-annealing loci, allowing for exponential target amplification, and a strand-displacing polymerase, which removes the need for expensive thermocyclers. We have been optimizing this for dengue virus diagnosis, but it can also be applied to parasites and bacteria as well. We use a colorimetric detection method based on pH change, so no downstream analysis is needed, and it can be used as a single tube assay with a high degree of sensitivity. Using a device plugged into a laptop or a portable power pack or even a smartphone, all that is required is to heat the reaction mix to 63 degrees C for an hour to achieve detection of down to several nanograms of target DNA or RNA due to RT inclusion in the mixture. I thought this might be an interesting topic for discussion, as this area of diagnoses for resource-limited settings is in an area I am very interested in, and I believe that this assay has great potential to expand the diagnosis capabilities of mobile clinics/doctors like you describe in your show. Thanks.
Interesting.
Indeed.
No, I appreciate that, Alistair. This actually, I have to admit, I also find this to be an exciting area, because these isothermal amplification approaches don't require these expensive thermocyclers. And they've been moving into a lot of different diagnostics. So I think that this is going to be growing as far as a diagnostic approach in resource-limited settings. And it's great that you're working on dengue viral diagnosis. And then hopefully your next step will be all these wonderful parasitic diseases.
You're here. Remind me again what LAMP stands for.
It's a light.
It's
No, actually, no, you are right. So it is an acronym.
Loop mediated isothermal amplification.
Exactly.
Well, that clears it up.
It's here's a paper in Reviews in Medical Virology. It's a powerful, innovative gene amplification technique emerging as a simple, rapid tool for early detection and identification. It's very simple, as he said, at least less than an hour.
Sounds good.
Very cool. LAMP.
All right.
Yeah, you can turn on the lamp. We had 8 guesses. There you go.
8.
And there were different ones. We had
Indeed they were.
scabies. We had the little cutaneous larval migrans, right?
Yep.
Am I missing something else?
The ectopic schisto.
Yeah, ectopic schisto.
I guess that was non-human schisto. Yeah, like bird
schisto.
Bird schisto is very common for skin disorders.
Well, there you go. So, Daniel, what happened next?
Exactly.
Yeah, well, I think before I do any more, I noticed I can see Dickson the way we're set up here, and Dickson seemed like he was sort of agreeing or more animated when a certain diagnosis was being read about. I don't know if you wanted to chime in at all, Dickson, before I give any more information.
Sure, I've already got a book, but I'll guess anyway.
You don't get a book.
That's true. Maybe I don't get to write into the next edition. No, my first impression didn't change after all of these guesses based on your original presentation of the case last TWiP, and I'm going to guess that it's Sarcoptes scabii. The place for the mites, though, is not usually all over the body. I must say that cases of scabies and even chronic infections that are not due to an incompetent, immunomodulated person, like, for instance, someone who would have Norwegian scabies might have that condition, and so therefore they would require additional therapy. You'd find the scabies in between the webbings of the fingers, but the rash is never in the webbing of the fingers. It's along the trunk and the back, but behind the knees and in places that you would least expect it based on where the scabies mites actually live. So this rash is very typical for scabies, and particularly in children. And children are all over each other, playing in the mud and playing all kinds of games and everything else. And they're always exploring each other's bodies, and they're rubbing hands all over each other. And this is an easy way to transmit this from person to person. So I think scabies is the best thing to go with here.
I must say, last week when you were reading it, Daniel, he was poking the webs of his fingers.
I actually did that and showed Vincent that's where I think these things are, and you agreed with me.
What do I know? What do I know?
Oh, you know a lot more than you are letting on.
I don't know anything.
Yes, you do.
I know viruses.
You do. Well, we're bringing you up to speed here.
It's been 151 episodes.
That's right. Exactly.
I think you are a seasoned parasitologist at this point, Vincent.
Yeah, that's right. Exactly right.
I would put you up there.
I need some field work.
This can be arranged.
So yeah, let me go through, and one of the things I liked, I was glad people jumped in with a few references and comments about the dermoscopy, because that was actually part of one of the things here. So the first thing I'll comment about was the distribution, and when you learn about scabies, and I'm going to say it's scabies, and we'll work towards why. When you learn about how it presents in the temperate climate, you really, I think there's 2 classic presentations that people see. So the one that Dickson was pointing out, you often see these in the webbing between the fingers, and or you see this extreme in the immunocompromised, where you see what they call the Norwegian scabies, and that actually goes back to a description in Norway, not something necessarily particularly prevalent in Norway, at any point, but it was described in Norway. It got this name, and that's where you have such severe infestation with scabies that you see basically this thickening on the hands and other parts of the body. Actually, the entire body can be covered with this thick coating, and it was actually even between the time we presented this case and now, there was a case of an actress who died in a nursing home.
Just saw that today on the news.
Did you see that?
Yeah.
And she had developed such a severe case of Norwegian scabies that she'd actually died.
She was 93 years old we should
93
add.
years old, sort of, not particularly
Neglected.
to.
That's right.
Yeah, that is the right word. Neglected in a nursing home. The scabies had gotten so bad, and it was not recognized.
Right.
And I think that that's hopefully something we're doing here, is that we're pointing out, and some of our people emailed in pointed this, you don't have to go to the tropics to see this. I see scabies on a regular basis here.
Sure.
Some of the clinicians that wrote in were commenting that they see it. There's a lot of clinicians that don't realize they're seeing it. But when the floating doctors originally went to some of these villages, 20% of the kids had scabies. Now, one of the challenges that I encountered the first time I started seeing patients in the tropics is the presentation of scabies in the tropics is different than the presentation of scabies in a temperate climate. And I like, if people have their 6th edition, if they go to figure 39.8, which I open, which I sort of like, is that you do see involvement of the hands, but you actually quite often see the scabies involving the buttocks. Sometimes you'll see a little bit of extension into the genital area. You'll see it on the elbows. It's a very interesting presentation, which is much more diffuse and not quite the characteristic that you see. I do a slide where I actually take this figure and then I add a few. Sometimes you'll actually see it in the scalp. I've seen some pretty severe scabies in the scalp, which then gets super infected. So it's a much more diffuse, different presentation. So in my mind, there's the typical temperate, low infection scabies where you see a lot of it between the finger webs. There's the Norwegian, immunocompromised, severe, and then there's this tropical childhood scabies. But also in the tropics, you see low incidence. The people going to these areas to help can often get infected with scabies because there's just so much of it around and you're taking care of these people. And one of the things that I thought was nice, we talked a little bit about resources being limited as far as the diagnosis. And the nice thing with dermoscopy is you may not have a microscope with you, but one of these $200-$300 dermoscopes can fit in your pocket. And you can actually, these little chevrons or triangles that I was describing, you're actually seeing the heads of the mites. And so you're really sort of confirming this, which is because these are ectoparasites. These are not, virus size, not bacteria size. They're to the size where when you amplify to about 10x the image and have the ability to see a little bit down into the skin, you can actually see the burrows and you can see the mites. That's
amazing.
So it's a great technology to really be able to confirm. And then when you treat these patients, they are quite happy. There is that delay, which people wrote in, because once you kill the mites, you still have the feces, you still have this itch that then is going to last, I'd say, a week or two in general.
Yeah.
And what you're hopefully trying to do, and what I think Floating Doctors has succeeded in doing, is the more people you treat, the more transmission interruption occurs. And you go from a village where 20% of the kids have this down to less and less. And some of the villages that have been visited quite frequently for years are starting to have almost an absence of scabies. So
this is an exclusively human infection.
That's correct.
Infestation.
There are no reservoir hosts for this.
We could get rid of it in humans, and that's it. It's gone.
We could. So I remember back in my early days at Columbia as a technician, back in the 60s, early 60s, this was not too long after the Korean War. The Korean War ended in 1953, but that had ramifications much later on in the history of that country, particularly South Korea. And a lot of orphans from Korea came to the United States under compassionate immigration rulings by the government at that point, which I believe was, what is that, Eisenhower? I'm trying to guess who was president, or Kennedy. And Kennedy was in
54, you said.
50. No, I said in the 60s. Now we're in the
Kennedy,
60s. Yeah, Kennedy. So the point is that almost all of those children that came from orphanages in Korea had scabies. And it was well known that was a group that everybody should pay attention to. But in those days, we didn't have ivermectin. So what did they do? They used a variety of other approaches to it. And some of the medications were deemed quite harmful in retrospect because they were very powerful chemicals that they were using. Some of them were shampoos. Others were powders that they would dust, and sometimes they would even dust the areas with DDT.
Yeah, there was neurotoxicity. Some of the earlier treatments.
Exactly. So they were using insecticides, basically, included into lotions and to powders to try to counteract this. And they might have even ended up doing more harm than good by trying to get rid of the scabies and inducing, other things which they were not aware of at the time, but later on came to realize that they were perhaps doing something that they should have probably realized. The USDA and the EPA were not in existence at that point. So the USDA was, of course, but the EPA was not, and we didn't have a Food and Drug Administration that was quite active at that point. So I think, thank goodness for the emergence of ivermectin and albendazole, as we will hear later on in our summary for the hero of the week, as a matter of fact. But we won't spoil it by telling you who that is right now.
Yeah, no, I like this case too for a couple of reasons. One is I like your aside there, because you go to a lot of these areas, and it's amazing how common this is in certain populations. And you think of, we complain about, I don't know what we complain about, but you could think of, 1/5 of the children have these horrible ectoparasitic infections that are like making them scratch and itch and they can't sleep. And I mean, it can be miserable. And it's something, as we'll discuss coming up, that can be very easy to treat. And as we discussed, that poor actress who died from neglect in a nursing home, basically being eaten alive by scabies mites. This is, I think, underappreciated. I often get people sent to me with you have delusional parasitosis, and actually a course of treatment, and the delusions went away because they weren't delusions. They actually had scabies. Yeah. And So
Daniel, with so many people infected, how do you deal with that as a problem that won't come back as soon as your floating doctors go back home?
Well, I think that's what they try to do, is that the people learn after a time, hey, I can actually go with this horrible itchy rash and get that medicine. And then as the trust and the relationship develops, more people get treated, and then you have less spread of this. I mean, so there's a couple of things that are going on. I guess we'll get into treatment. It's pretty hard, I think, as one of our emailers write in, to cover the entire body with an insecticide cream. And the permethrin cream is often what's used. But just before I get there, I want to make another sort of plug for the importance of the diagnosis. Because this presents differently in the tropics, when someone goes there and they're not familiar with this presentation and they see a rash involving, let's say, the scalp, for instance, in a small child, they might think, oh, it's a fungal infection. Sometimes the fungal infections have a super infection with bacteria. They may not be considering scabies, but they just listened to our show, so now they are. The dermoscopic appearance allows one to distinguish between a scabies infection and a fungal infection. So the scabies, as we described, you're actually going to see the burrows, you're going to see these brown lines, and you're going to see the little chevrons, the little triangles, which are the mites. With a fungal infection, you tend to see these little commas. And so you can actually, with a dermoscope, make that initial diagnosis. Oh, this is fungal, this is scabies. If it's scabies, as mentioned, we might use a permethrin cream. If it is fungal, then we're actually going to use some sort of fungal targeted therapy, and then make the decision if there's a secondary bacterial issue to treat as well.
So what'd you do?
All right. So people actually brought up, so I already mentioned the permethrin cream, but in severe cases where it's the entire body like this, and you sort of think about the logistics of covering these children from, neck to toe, I guess, we'll often do a little bit of topical permethrin. We'll give the parents a little bit to use in some of these areas, but we'll actually go ahead and we'll use ivermectin.
Right.
And it's a 2-dose thing. So we'll actually go ahead and an initial dose, and then we repeat this in a couple weeks. And I think, as I mentioned, when they're in these communities where there's a lot of it, they may get it again, hopefully not as bad an infection the second time, and then, boom, they get hit with another round of double treatment.
Yeah.
And I've actually, and this has been in different settings, when it is so severe or crusted or recalcitrant, we actually end up with these sort of almost pulsed dosing of ivermectin, where it's 1, day 2, day 8, day 9. Then we go out to 15, and then maybe even 22 and 29 I've had to do in really severe cases. This is ivermectin dosing with permethrin cream.
Wow.
It can be hard to treat. And I think it's, as an ID specialist, you get referred often the recalcitrant, difficult to treat patients.
So interestingly enough here, this is a multifaceted drug that has lots of effects for various groups of organisms. And these little kids would certainly be candidates for acquiring things like strongyloides and hookworm and ascaris, maybe even pinworm. They've all got pinworm. But so you're giving them a drug that may actually be curing them about 4 or 5 different things in addition to their scabies.
No, this is true. This is true.
Daniel, when you were there, did you see a lot of these cases?
20%, he said. Right?
In this village, this village is still an area where it's pretty high endemic. So there were a lot of little kids with this. But hopefully, as years go by, we're going to see less and less. But no, we were seeing about 100 patients a day. I guess that's actually typical for these mobile clinics for floating doctors. And if you think about that, these populations have that sort of demographic shift where of those 100, the majority are children. And so let's say 75, I'm trying to figure out a number I can do the math with. So we'll say 60 just because it's easier for me to divide. And then say 20% of that, those kids are going to have. So this was something you just saw a lot of.
Remarkable.
So 20%, what was the second most common thing you saw?
A lot of, I would say all the kids, right, they have ascaris. And I remember actually talking a little bit with, communicating with Ben a little bit about this, Ben Lebrot, who started Floating Doctors. And he's like, oh, no, they all go in these toilets. The little kids, I talk to them. They don't go in the toilets. Parents might go in the toilets. The kids might go in the toilets sometimes.
You mean the ones that hang over the docks?
Often, if they're out there playing ball and it's time to go, it's time to go. I'm not going to go home and go in the, So when I talk to them, I have a blast joking with like, how big are they? I've got the arms like spread as wide as I can.
Right.
They've all got visible ascaris, the little kids.
So do you do a deworming drug as well, like albendazole or something like that?
They do, and I was just this week reading through the WHO comes out with sort of guidelines for soil transmitted helminth deworming programs, and talking about should you do it once a year, should you do it every 6 months,
exactly.
And in these areas, they're trying to come a minimum of every 3 months. So they have a lot of these villages in like a Q 3-month deworming protocol. And I think that's reasonable with the degree of worm burden that these populations have.
So I actually asked that question on purpose because of the follow-up that we're going to have with the paper that we're going to review today. So we'll come back to this concept of community treatment in another way when we get to the science topic for the day.
Oh, excellent.
Science topic?
Yep.
All right. You mean hero?
I have a hero. Want me to do
not
the
yet,
hero?
Not yet, no.
I didn't think so.
What are you talking about science topic? You mean the paper? Oh,
yes.
You're a little obscure sometimes,
Well, I wanted you to try to guess.
We have to give away a copy of PD6.
We do.
We don't have to, but we like to.
No, right? I would love to give away a copy.
Yeah, we do it every week or every episode. Yep. And here we had 8 submissions. I'm going to pick, I go to a website called randomnumbergenerator.com. I plug in 8 and I click generate a number, and the number is number 3. Number 3, who's number 3? Number 3 is Alice from Syracuse, the Golden Snowball Award winner. So Alice, I do have your address. However, I would like you to acknowledge that you've won. Makes you listen.
This is true.
And if there are others out there who have not received... Oh, Daniel just left us.
Yes, he did. He'll be back.
There are others out there who have not yet received your book. Let me know, because sometimes I don't have good record keeping.
Uh-oh. Was Alice one of the ones that got it right?
No.
Well, then the book will even have more good than...
No, she picked... Ancylostoma brasiliense.
It's not a bad guess. It's
the Canis larva migrans.
Yes, but it doesn't really induce that much itching except at the site. whereas this thing was a rash that was all over your body. And that's okay, because we've got the information right in the old 6th edition, and you can go find out more information about this, Alice, and I hope you have a good time with the book. We're waiting for our colleague to return. As my 2.5-year-old grandson would say, poor connection, poor connection.
Is that what he would say?
Yeah, we get him on FaceTime. We get him on FaceTime sometimes, and he says, poor connection.
I think Long Island sunk.
Hello, I lost you guys. Is my sound quality terrible?
Ooh, is that what happened? Where'd you go?
So we lost power, complete power. So
Whoa.
Did you really?
How about that?
Was there a lightning bolt or something?
I have no idea, but the entire place, no electricity. So I've got an iPad set up like on a windowsill.
Holy shit.
And I'm sitting here in the dark.
All right, we can deal. We'll deal with it. It's fine.
Good heavens.
How about that?
That's weird.
You suggested that, Dickson.
I did, didn't I?
Okay.
Wow. Sorry about that, Daniel. Now you'll have to go sailing.
Okay.
All right, let's do our paper.
You want to do the paper? Okay, here we go.
Dickson, you picked this paper?
I did pick this paper because I wanted to get into an area that ordinarily didn't involve parasitologists, that were studying parasitism as a way of viewing ecological associations. And so this paper the title is called Competing for Blood, the Ecology of Parasite Resource Competition in Human Malaria-helminth Co-infections. And there are lots of authors on the paper, as is typically the case with these kinds of studies that involve other people's data that they have to access in order to make the connections. There's Sarah Budashak, Apriliato E. Roria, Fridaus Hamid, Linda J. Wamas, Maria M. Kaiser, Lizette Van Lieshout, Arieliani Sartuno, and Taniawati Supali, Maria. Oh boy, I'm sorry, Maria, but I'm going to probably wreck this name.
Baksh.
Thank you. Yazba Baksh and Andrea L. Graham.
They are from Princeton University, Leiden University, and Universitas Indonesia.
Exactly.
Jakarta. Ever been to Jakarta?
No, I have not even been to that part of the world.
I don't think you've been to Princeton, have you?
Oh, yes, I've been to Princeton many times. So the abstract is very clear as to what they're.
Did you read the title?
I just did.
What's the journal?
The journal is Ecology Letters, and they publish a lot of research that's in progress or small studies that have to do with specific issues rather than large ecosystem studies, for instance, that are ongoing for long term. These are short-term studies for the most part, but in this case, let me just read this abstract to you, and then we can start into the actual interpretation of the data. Ecological theory suggests that co-infecting parasite species can interact within hosts directly via host immunity and/or via resource competition. In mice, competition for red blood cells between malaria and blood-sucking helminths can regulate malaria population dynamics, but the importance of red blood cell competition in human hosts was unknown. We analyzed infection density, i.e. the concentration of parasites in infected hosts, from a 2-year deworming study of over 4,000 human subjects. After accounting for resource use differences among parasites, we find evidence of resource competition, priority effects, and a competitive hierarchy within co-infected individuals. For example, reducing competition via deworming increased Plasmodium vivax densities 2.8-fold, and this effect is limited to blood-sucking hookworms. Our ecological resource-based perspectives shed new light into decades of conflicting outcomes of malaria/helminth co-infection studies with significant health and transmission consequences. Beyond blood, investigating within human resource competition may bring new insights for improving human health. So all the data were there, and all they had to do was piece it together in a way which actually made sense. Okay, and they applied lots of interesting statistical methods to tease out from this very complicated set of infections, the effects of blood-sucking helminths and red blood cell damaging intracellular parasites, namely the malarial parasites. And they looked at two different kinds of parasites. And in fact, this study was done on an island which has noted fame for yet another reason. There is a small dwarf form of hominin that lived there, the fluorescens hominin, and we can look that up on the internet as we were speaking, because it's an island community, and they've got lots of malaria there, as well as geohelminth infections of ascaris, hookworm, and strongyloides. And so they had a lot of resources to deal with, and because it's an island, they could effectively deworm the entire island if that's what they wished to do. And so over time, that's exactly what they did do. Now, what is the effect if you remove...
First, before you say that.
Yeah, sure, go ahead.
They looked for malaria.
They did.
You would look that in the blood, right?
And they had two different kinds of malaria, Plasmodium falciparum, which is the more dangerous of the two, that they looked at, in Plasmodium vivax.
So blood sample PCR, right?
That's correct. And now they quickly pointed out that Plasmodium vivax has a penchant for infecting young red cells. Like reticulocytes. Mm-hmm. Whereas Plasmodium falciparum has no preference. Shows no preference in terms of its host species for red blood cell.
And what about the helminths?
The helminths were of two kinds, non-blood sucking and blood sucking. Mm-hmm. Okay, so ascaris is a background infection, and we've already talked about that. Daniel, of course, raised that issue down in Panama, and anywhere you look in the tropics, the pediatric population is just loaded with ascaris.
Right, non-blood sucking.
But
how did they assay ascaris in these people?
They did a lot of PCR analysis for the actual DNA of the organisms.
In the feces?
Yeah, and they tried to relate the intensity of the PCR reaction to the worm burden and tried to correlate that with what they call classical egg counts that would tell you how many adult worms for each of these species were there.
You would count them in the stool.
You would. You can do an egg count. It's a classic study, but it's a laborious process and probably not worth it. So here we've got this group of ecologists taking data, and they also preserved the specimens after they extracted the DNA and brought it back to the lab and performed all the procedures back in at Princeton and at Leiden University. All the data were collected in Indonesia. And then they
have these data before and after the deworming.
The deworming was ongoing, so they had some populations that hadn't been dewormed yet and other populations that had been dewormed, so they were able to compare the two groups.
And the deworming is with albendazole?
Albendazole.
Which is going to hit the ascaris and the hookworms. Right?
That's correct. And strongyloides too, by the way, but it will not affect malaria parasites whatsoever.
Right.
Okay, they didn't give any antimalarials, in fact. And so what they were looking at was whether or not a known blood-sucking parasite, namely hookworm, and they had two kinds, Ancylostoma duodenale, which was only 7% of all the hookworm they saw, and all the rest were Nicatera americanus. Now, it's important to point out that Ancylostoma duodenale sucks 10 times as much blood as Nicatera americanus. So if all the blood-sucking worms were the ones that sucked not a lot of blood versus only a couple of percentage worth for these high blood-sucking parasites, the effects were remarkably predictable because there were two kinds of malaria infections, and of course there's a season for that, so they had to be there at the right time to actually time these collections for the height of these transmission cycles. So it was complicated for lots of different things, but nonetheless, they were able to conclude some very interesting points. And number one is that blood-sucking helminths affect the levels of parasitemia in malaria cases. In the first case, with blood-sucking helminths, you had a higher rate of infection with Plasmodium vivax than you did if you didn't have blood-sucking parasites present. And the reason for that is that hookworm causes an anemia. And the anemia is characterized by a lot of young red blood cells pushed out into the blood supply to try to compensate for the loss. Okay, so that's
before deworming.
They didn't even mention that, but that's actually what's happening here. So what's happening in a hookworm infection, of chronic hookworm infection in children, is that you've got a parasitemia from a malaria that goes crazy because you've got a lot of susceptible red cells that are being produced as a result of the
which Plasmodium?
The Vivax.
It says here, individuals co-infected with either of the hookworms had lower density Vivax infections.
Well, there's a graph that actually disputes that. At least that was my.
I think that was before deworming.
No, I can show you that graph that I.
Daniel, you there?
Yeah, I'll jump in. I don't know how good the sound quality is.
Jump.
But so this is an interesting thing you're bringing up. So they do show figure 2. Actually, they just basically say deworming increases Plasmodium vivax.
Yeah, that's
density.
right. That's right.
And so the idea here, I think, and I wish there was a little more data, I'll be a little critical of this article, is that the idea they're going to put forth in their discussion is that when you have a chronic hookworm infection, that you're going to end up iron deficient. Because of the iron deficiency, you're going to have less reticulocytosis. You're going to have less of these early forms of the erythrocytes that the Vivax is exclusive. So Vivax can only infect young red blood cells, which we refer to as reticulocytes. When you're iron deficient, you can't make as many reticulocytes. So you basically have less.
Oh, all right. Okay, so I had it reversed. Okay.
Yeah, but that's okay.
So go ahead.
Interesting thing I'll say at this point, and I guess sort of, we'll get more into this, but their deworming approach is, I think, important to consider. Vincent, you asked about this. They're doing albendazole every 3 months as a single dose. And they talk a little bit about the efficacy. But one of the differences, if you really want to hit ascaris, 1 dose is enough. If you're really trying to hit hookworm, you do a lot better with 3 days.
Right.
Yep. So there were a couple things I would have liked to have seen is if they really wanted to target hookworm, do 3-day regimens. The other is I would really like to see the reticulocyte counts change and then see that correlation.
That's another good point. So, I mean, these are difficult studies because there's a lot of confounding background noise that relates to diet. It relates to the seasons of transmission for the parasites. It relates to how long after they gave the drug before the worms start to come back. There's a whole bunch of variables here that I was really concerned about because as I read through this rather densely worded paper, because ecologists differ greatly from lots of other people because they want you to know all of the background. They want you to know all the nuance of host parasite interfaces and competition for resources and all kinds of things that are not considered, let's say, in most medical publications. And so for that reason, it's a difficult read for people not always exposed to that kind of literature. And it's easy to get confused as to what happened because these are not parasitologists; these are ecologists trying to keep track of this onset of changes, and they used some very involved statistical methods, which, obviously I'm not a statistician by any means, and I always relied on people that had knowledge in that area to make up for my deficits. But the fact is that they were able to ultimately conclude that red blood cell resources were affected by malaria and by helminth removal. So, I mean, I can just read the results almost, and you can hear for yourself that after reading the results, you might still be confused as to what the result actually was, because you can see these things graphed out, and I'm looking at these diagrams, and these are unusual ways of expressing data as far as I'm concerned. But so none of the 4 focal parasites affected red blood cell counts, but a treatment by Plasmodium falciparum interaction was detected. Contrasts revealed that dewormed individuals had similar red blood cell counts regardless of P. falciparum infection status, but control individuals infected with P. falciparum had lower red blood cell counts. Well, of course, because it's a parasite that it eats red cells. A similar pattern was observed for Necator americanus, but the interaction was marginally insignificant. If parasite density within infected hosts rather than presence or absence was examined, a negative relationship between Plasmodium falciparum and red blood cell count was detected. Vivax density interacted with treatment such that among control individuals, there was a non-significant negative slope between density and red blood cell count, but among dewormed individuals, this relationship was slightly positive. And I think that's where I got the idea that Plasmodium vivax was involved in that. The densities of the two helminths were not associated with red blood cell counts. So they were not actually anemic because of these helminthic infections. Effects of co-infection on red blood cell count was difficult to detect because treatment status interaction with infected status, i.e. none, only hookworms, only malaria, both parasites, prompted the need for 8 separate contrasts for each malaria species, none of which proved significant. Then they have a long discussion as to, what the true meaning of these observations were, and then what needs to be done next to further pin down what's going on. And I selected the paper based on the fact that you may not come away with a definitive answer on this, but at least you've got groups of people with backgrounds in ecological process interested now in parasitic relationships, which is not that it's unusual to see, but it's unusual to see people from such places as Princeton University and Leiden, which has a long history of biodynamics and ecosystem studies and this sort of thing, to see them now tackling some very intricate host-parasite relationships, which in a natural setting, remember they start out telling you how obvious it was in mice, not so obvious in people.
There was one other thing. They showed P. falciparum density declined with age, and P. vivax is independent of age.
And the other thing they said, of course, was hookworm tends to not do that. It can be present in children.
Well, Americanus increases with age,
that's right.
And Ascaris declines with age.
Exactly. But so that Ascaris is not a blood-sucking worm. So that no pun intended, but that was a red herring that they threw in because it was present in every child and every person they looked at. I'm certain of it.
They make the statement that there may be net health benefits to deworming despite an overall association with higher P. vivax.
Oh, you know what? Peter Hotez would just absolutely jump out of his chair if he heard that statement.
There may be net.
There's not maybe. There is an obvious, there's an obvious relationship between the ability to learn and the presence of geohelminths. Mm-hmm. Particularly hookworm, because it causes stunting. It's known as an endocrinopathy, which is poorly understood. No one actually knows the reason why hookworm infection in children causes stunting, but that's classic for this parasite, and you end up with an inability to reason properly as an adult. So
could it be, as ecologists, they're not aware of this?
Well, they don't read the same literature, I can guarantee you that. So maybe that's the case, but they're pretty thorough in their examination of this problem from a host parasite standpoint.
I love this statement, Dickson. They say, while hookworms could share the preference of P. vivax for reticulocytes, they are considered to be indiscriminate bulk feeders that cut open blood vessels and eat all the red blood cells that flow out.
They are bloodsucker. That's actually not true. And I did want to correct that statement.
They're indiscriminate bulk feeders?
Well, what do they eat? The point is that they do suck blood from the site that they bite off a piece of villus from, and the blood continues to bleed because the hookworms inject anticoagulants into the site to keep it flowing. And the blood does actually pass through the gut tract of the worm, and they do knock down the red blood cells and open up the hemoglobin, and they've got hemoglobinases and all kinds of cysteine proteases and stuff like this that have been recently discovered. So it's proven beyond a shadow of a doubt that hookworms eat blood, but they also eat the villus tissue, which is a much more protein-dense solution. So when they leave the site of the bite, it continues to bleed for 2 or 3 more days. And that's where the anemia really comes in, because it's not just about the food for this parasite. They continue to do that, whereas malaria parasites, they don't do that. They just go into red cells and eat the hemoglobin and go to the next one.
By the way, they say indiscriminate.
Indiscriminate, right.
But it's indiscriminate.
They eat everything.
It's misspelled.
Okay.
Indiscriminate.
Well, we can at least find something to criticize on this that we can both understand.
Daniel, would you not agree that there is a good reason to deworm despite the increase in vivax?
Well, I would say it is interesting. And I sort of noticed that, when you start going down an area of investigation where you're asking a little bit about the global impact of deworming, I think it's okay. I mean, this is science. And we're not saying here, stop deworming. But if you go to an area where the major problem in the area is death from vivax, and hopefully we've tried to point out that falciparum is not the only malaria that kills people. So if you go into that area with a massive deworming campaign, you may also want to have an associated massive bed net, mosquito control, malaria prevention.
That's right.
And I think this reminded me, I was actually talking about this paper to non-parasitologists about when the whole big introduction, billions of dollars, we've got to get iron to all these kids because they're iron deficient. They're not learning well.
Dangerous.
And there was a huge mortality increase. So those kids, they died. They're learning nothing. So if you go into an area where they're saying you may have to contend with an increase in the vivax density, you may notice an increase in malaria deaths in those areas. I think it's important for us to know that and then bring a program that's going to address soil-transmitted helminth, but make sure that there isn't an untoward consequence that
totally agreed.
This science is suggesting we need to keep our eyes open for.
The establishment of Bangladesh was also greeted by a number of NGOs and other health agencies to try to address the issues of Bangladesh as a humanitarian act to help the country get up on its feet, because it was obviously one of the poor portions of Pakistan. So what they did was they realized that everybody there had malaria and everybody there had hookworm, but they reckoned that the anemia from hookworm was much more severe than it was from malaria. So they started with iron therapy. Daniel is absolutely right on the money, because about 3 or 4 months after they started that, there was an enormous increase in the death rate in children, because malaria doesn't do well in an iron-deficient individual. It needs healthy red cells in order to survive. And if you deprive them of their proper nutrition, they're not going to do well. And then giving iron therapy immediately reestablished the red blood cell count and the healthiness of the hemoglobin inside of each one of these red cells. And it was a horror show, because, the best intentions, everybody wanted to do good for this country. And the next thing you know, of course, everybody was suspicious of anybody coming in to try to help them after that. Sure. And maybe they were helping them in nutrition and with water. There's a whole history of, I would call it inadvertent malpractice at a community level, where people, they don't really look through the situation enough. They don't do trials first. They just say, we've got all this iron pills here. Please take them. I know that they're going to do some good. And then they're surprised at the results.
One thing we haven't mentioned, which is important, is that this twofold higher malaria density probably would make a difference in terms of symptoms and mortality, right?
No question. No question. Absolutely no question at all.
All right.
It's, I'm sorry that it was not as sexy in the quotes,
no
molecular approach.
Apologize.
No, I'm not. I'm just saying.
Well, you said I'm sorry. That sounded like an apology.
Well, it's sort of it's not an apology. Let's just put it that way.
I'll tell you what. Let's have a hero, and you can make up for it.
Oh, I would be happy to do that.
Yes,
absolutely.
Daniel.
Happy. Daniel, you have more to add here?
Maybe his battery died.
Oh dear. Well, we're almost set for the wrap-up, because we're not going to get another case.
We need a case from Daniel.
We do need a case.
A case from Daniel.
I know that. So I'll read slow. Maybe he'll come back. Oh, he's back. He's back. Okay. So I've been reading from our 6th edition textbook, and I've been going alphabetically, and we've gone through the B's, and now we come to the C's. And the first C we come to is none other than William Cecil Campbell, PhD. Born in 1930, fortunate for everyone in this planet, he's still alive and still healthy and still active. And here's a little bit of a snippet as to why we have selected him as one of our heroes. William Campbell, Satoshi Omura, and Oyoyo Tu received the 2015 Nobel Prize in Physiology or Medicine for therapies that revolutionized the treatment of certain parasitic diseases. Together with Satoshi Omura, Campbell discovered a fermentation product from a soil-dwelling bacteria, Streptomyces avermilitis. The antibiotic was called ivermectin, which proved to have remarkable anti-helminthic properties. A derivative, ivermectin, is commercially available and is the drug responsible for eliminating the filarial worm Onchocerca volvulus, river blindness, from most of West Africa. This work was supported in part by the Carter Center, Merck, and the cooperating countries in West Africa. Other helminthic infections, both human and animal, also are treatable with ivermectin, as we've discussed today with our scabies case. For the seminal work, Omura and Campbell shared the 2015 prize in physiology or medicine. Now, I must say that I've known Bill Campbell for most of my research career. I was a postdoctoral fellow at Rockefeller University when we became close friends. And actually, I'd known him before this too during my thesis work, but I really became a very good and close associate of Bill because he was generous with not only his time, but also his resources, and supplied for me at one point in my research a large cylinder filled with purified trichinella larvae that filled the cylinder up to the 175 mil mark. I have never seen in my life as many trichinella larvae in one place as I did that particular day. We were extracting subcellular particles from the worms in order to show which particles belong to which cells inside the stichocytes of these parasites. And Bill has a fondness for trichinella, too, because he wrote a whole book on trichinella called The Biology of Trichinella. Trichinella and Trichinellosis was the title of the book. I should retract that and say that that was the title. And I had the privilege of writing this section on the biology of the parasite. It was written in 1983, and it cemented our very, very close relationship. I had the pleasure of calling him and congratulating him on his Nobel Prize.
Born in Northern Ireland, you know.
He was born in Northern Ireland. Now, some interesting facts about Bill that probably not a lot of people know is that he was homeschooled until he got to college. And then he went to Iowa State University, or he was either Iowa State or University of Iowa, and studied there and became associated with a group that had done some research on trichinellosis, because in Iowa they raise a lot of pigs, and at that point in his career that was still a problem in this country.
There's a lovely history he wrote for the Nobel site. I'll put a link to it.
Oh,
it
great.
goes through his whole life, and he counts as one of his three mentors J.D. Smith, who was the author of the book that we just mentioned earlier.
Exactly. And I think your wife knew him pretty well, too,
she did. She knew him at Merck. They worked together. She worked on ivermectin when she went there in 1980s.
Wow.
So she knew him for quite a while, yeah.
And he's the most gentle, interesting, funny, verbose at times. He's got part actor's blood, and he's been in lots of plays. He loves it. He's a big fan of the microscope, so he's amassed a small collection of ancient microscopes as a way of showing the progression of knowledge, so to speak. And he had the largest collection of articles dealing with the germ theory of infectious diseases that you could possibly imagine. I mean, he had boxes filled with alphabetized cards on all the subjects leading up to the conclusion that diseases, many of them, are caused by microbes of various sorts. You know, the old Koch's postulates and things of this sort. He's an encyclopedic investigator. When he does something, he does it completely thoroughly. And I had the privilege of actually having my name on a paper with him. And so I'm deeply honored to be able to read his little bio here, which is a tip of a very large iceberg, and to tell you that this life is worth looking into. He's really made major contributions. He's also an artist. I mean, he draws pictures of parasites and then paints them, and then they're auctioned off at the American Society for Parasitology. A former president of the American Society for Parasitology as well. So
you're an artist also, aren't you?
No, I like to dabble, but
Daniel, you still there?
I think we've just put him to sleep.
I am still here. Can you guys hear me?
Of course.
Yeah, we can.
Absolutely.
We're wondering if you have a case for us.
Yes.
I do, and I hope the sound quality is good. If it's not, I'll re-record or something. But here we go. This is a woman in her 30s, and she is actually the mother of those last two boys that we saw.
Oh, wow.
And so I thought this was, and we often get that. You get the whole family sometimes, and sometimes the whole family is 10, 11, or 12. It could be pretty big families. An aside, actually, we were talking to them one time about vaccination, and someone mentioned, there are certain people in the U.S. who don't vaccinate, and one of the mothers looked at us and thought for a while, she said, "Oh, are the families too big?"
Yeah.
It's sort of interesting. I mean, here's a place where they have a very different experience. But here's this mother, the mother of these children. And so you can remember, we have traveled to this remote island. We're in this little village. We've traveled up the river. There's a few hundred people living in pretty primitive setting. And that's actually going to play a part in the story. And the mother is concerned about abdominal pain that she tells us she's been suffering from for 3 years. And she reports that she has been having a fullness, sort of a bloating, a swelling of her lower abdomen. She says that she has not noticed any blood in the stool, but she does note occasionally she has loose stools, so kind of a chronic diarrhea here. It's a little bit difficult for her to clean. So the stool is kind of a sticky, pasty, greasy, I will say, stools. She reports no variation in this pain with her menstrual cycles. It's continuous. But with this going on for a while, she had previously made the long trip, several hours by boat, as we mentioned, to a hospital, where she told them about her symptoms. She underwent some testing, and they told her, "Oh, this is just an ovarian cyst. You need to get some surgery at some point." She returned to her village, and she's thinking about whether or not she should have surgery, and not really sure that's something she could even afford if it was the right thing. And another thing she's a little bit upset about that we learn as we talk to her more is she's concerned because she doesn't feel well and she no longer enjoys having sexual relations. And she's concerned that this is upsetting her husband. Her husband thinks that she doesn't find him attractive, and she's very concerned about that message because she still finds her husband very attractive. She just feels so bad from this chronic issue. A couple things to go through, and I think this is that she's been seen, as we mentioned, and had the ovarian cyst detected. She's been given omeprazole, and this didn't help. She's been given albendazole. This hasn't helped. She was given azithromycin. This didn't help. And so we're now asked to help. On exam, on her physical, she's got this diffuse abdominal tenderness. It actually does not localize. And then here, I'm going to throw a little bit of technology. We brought with us a portable ultrasound. So we take her, and we do an exam. We do an ultrasound exam, and we see a small left-sided ovarian cyst. It's about 1.5 centimeters, and it's not tender. This doesn't seem to be the localization to the tenderness. So I'm going to finish by saying, so here we are in this remote village with limited diagnostics. So we're going to try to make an empiric diagnosis of what might be causing this chronic abdominal pain with non-bloody, greasy stools. And we're going to try to empirically treat it and see if we can't make a difference.
Wow.
Hepatitis C virus.
Good Lord. I mean, the list is way longer than 3 in my head.
Daniel, would you call that steatorrhea?
I would. Yeah, I think that's the way she's describing it.
All right. Dickson is
No, Dickson's not doing anything.
Pointing at me.
No, he's not doing it.
Yeah, no, and what I'll say, to be honest here, is that I think we're going to end up, and maybe this will make one of our emailers happy, we're going to end up with a differential because we're not going to be able necessarily to confirm this diagnosis. We're going to have to do what we often do in these settings is say, based upon these symptoms, what are we going to do? And then what do we hope is going to happen?
Wow.
This challenge, this is often what happens in these medical missions. You're in a remote area.
Sure.
You don't have the resources. Wish you had to confirm the diagnosis.
Yeah.
I think actually the ultrasound was super helpful because she'd been carrying this diagnosis of an ovarian cyst. And I don't think the exam, the ultrasound, the rest was consistent with that. So we've at minimum probably saved her from an unnecessary surgery and all the challenges that would have posed.
Sure.
But I'm curious to see what people's thoughts are.
Wow. Okay.
And remind us, the water they drink comes from the roof, right?
Exactly. So they've got the tin roofs now, and they're collecting that, and that's their drinking water.
And what do they do for food?
It's limited. They eat a very starch diet, so there's a lot of plantains, there's rice, there's some fish.
Right. No pigs?
Oh, no, there's some pigs, there's some dogs, there's some chickens, so there's a little bit more going on.
Okay.
Yeah, you all set, Dickson?
No. No, I need to
think
cogitate.
about it.
I need to cogitate.
All right.
Yeah, absolutely.
Thank you, Daniel.
Yes, under duress, no less.
Pleasure as always.
It's like being in the tropics.
That is TWiP 151. You can find it at microbe.tv/TWiP and all the show notes, or on your phone or tablet. Just fire up your podcast player and subscribe to This Week in Parasitism. If you like what we do, you could support us financially as little as $1 a month. Go to microbe.tv/contribute and do send us your questions and case guesses to TWiP at microbe.tv. Daniel Griffin is at Columbia University Medical Center. Actually, it's now Columbia University Irving Medical Center, parasiteswithoutborders.com. Thank you, Daniel.
Pleasure as always.
Hope you get your power back soon.
Thank you.
Dickson Despommier is at Racaniello.org and also parasiteswithoutborders.org and many other websites, but we'll just mention two. Thank you, Dickson.
You're welcome, Vincent. This is good.
I'm Vincent Racaniello. You can find me at virology.ws. We thank ASM for their support and Ronald Jenkins for his music. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
is parasitic.
Is parasitic.
Is parasitic.